Hi, this is Leah from OpenIntro. In this video, we'll see how to carry out a confidence interval for a single proportion, one proportion Z interval, and how to find the minimum sample size for a given margin of error and confidence level. We are interested in estimating the proportion of students at a university who smoke. Out of a random sample of 200 students from this university, 40 students smoke. A. Calculate a 95% confidence interval for the proportion of students at this university who smoke, and interpret this interval in context. So we have a random sample, one random sample, and so since we're looking at a proportion, this is going to be a one proportion Z interval. Now we can check the conditions for a one proportion Z interval. We need one random sample, and we need NP hat and N1 minus P hat to be greater than or equal to 10. Unlike a test of hypothesis, there is no hypothesized P to substitute in here. So we must use the given sample proportion when we check our NP greater than or equal to 10. So we do have one random sample, and our P hat is 40 out of 200, and that's 0.2, so that is greater than or equal to 10, and our N1 minus P hat is also greater than or equal to 10. So now we can set up the confidence interval. It's always the estimate plus or minus the critical value times the corresponding standard error. Our estimate for the true proportion is our sample proportion, and that's denoted P hat. Our critical value is Z star, and if we're not sure of the structure for SE, we can grab a formula sheet, and for a single sample, the proportion, the standard error, is square root of P1 minus P over N. Of course, we don't have the true P, so we'll be using the sample P or the P hat. So if we plug in P hat there, we have the general form of our confidence interval for a one proportion Z interval. And now we can plug in P hat, which is 40 over 200. Plug in N, and all we have left is Z star. We may know the Z star for 95% confidence, but let's use a table so that we can see how to find it in case it's not 95% confidence. We go to the confidence level at the bottom, in this case 95, and then for a Z star, we always use rho infinity because this is a t-table, and as the degrees of freedom for the t-curve go to infinity, it becomes the Z curve. So for a Z star, always use rho infinity, the bottom row. And so here, we're going to have a Z star of 1.96, which probably sounds familiar to you. So plug that in, and now we're ready to calculate this. So we can pull up a calculator and do a shortcut and go to Stat Tests. This is a one proportion Z interval, so that's a one proportion interval, or a one prop interval, one prop Z int. And X is the number of yeses, which in this case is 40. N is the sample size of 200. Our confidence level is 0.95, and so we can do calculate. So just remember that X has to be an integer because it's the number of yeses, not the proportion of yeses. Okay, and so we get our interval here, and then let's record that here. We have 0.145 to 0.255. And so now we can interpret. We're 95% confident that the true percent of students at this university who smoke is between 14.5% and 25.5%. Part B. If we wanted the margin of error to be no larger than 2% at the 95% confidence level for the proportion of students who smoke, how big a sample would we need? So here we're interested in margin of error being no larger than 2%. So what we're really interested in is what's the smallest sample size that can ensure this? So first let's look at the structure of our confidence interval. The margin of error is what comes after the plus or minus. So this term here is the margin of error. And we want it to be no larger than 2%. So we want it to be less than or equal to 0.02. Make sure you put that as a decimal, 0.02. Okay, and now 95% confidence level, so we know Z star is going to be 1.96. And P hat, we have a P hat, we have a pretty good estimate for our proportion because it's given to us as 40 out of 200 is our estimate. So we have a p-hat to plug in, and we'll plug in that 40 out of 200, which is 0.2. However, if no estimate of p-hat is given, plug in 0.5 for p-hat. So usually you don't have an estimate of p-hat in a margin of error problem, so you just plug in 0.5 here. 0.5 if no number is given. Okay, now we have all our numbers plugged in, and so the only thing to do is solve for n. So we can divide both sides by 1.96 and then square both sides like this. And then we can multiply both sides by n and divide both sides by the term on the right. We get something like this. So being careful with parentheses, we get n is greater than or equal to 1,536.64. Now this is greater than or equal to that. So n being the sample size, of course, has to be an integer. So our final answer, which we can box, is n is 1,537. So make sure we put our final answer as an integer. That's it for this video. For more free resources, check us out at openintro.org.